So I'm going to be doing the quizzes that I created, the website. And then after some time, I'm going to do the data structures. So let me open, see if it's working. Of course. Not sure how much to do. I haven't done these quizzes since the last time that I streamed. I'm not really sure how long to do the quizzes versus how long to study the data structures. Not sure why it's taking that long. Usually it takes longer on the first time. I think it's to compile, but I should have everything compiled already. Not really sure what is going on. So probably the best thing to do is to open the other one while this compiles. Or I can look into the folder again. Rust training. So the first iterations, I'm just going to look into the solution because I'm not really 100% sure that it's correct or not. I reviewed a couple of them manually, the ones that I have marked with V here. But the other ones I just used an agent to go faster. So I'm not 100% sure if it is correct or not. I'm just gonna look into the solution of each one first. Then once I'm done and I verify that it works, then I'm gonna mark this with the V and move on to the next one. And the purpose of this, so like first, oh, this is actually the exercise. So let me go to the solution. So first, I'm gonna review the solutions, but then once I finish reviewing all of them, then the purpose is to rebuild the data structure myself, to force myself to think how I would rebuild it, and then I'm just gonna look into the solution if whenever I get stuck, and then do this a bunch of times until I improve at writing and understanding the main data structures or fundamental data structures. There's also this PowerShell scripts here that launch the exercise with Cargo, but do it manually as well. This is supposed to be a minimum vector implementation of the vector without using the vector, obviously. We're just using the standard alloc library. Also, I'm gonna read the documentation whenever I get stuck as well. Maybe last time that I changed the script, it bugged this. I'm gonna have to review that. So maybe it's probably better to do the quizzes first. It should warm up, maybe. Actually, I'm gonna skim this very quick, since I started now. Then I'll go back and do some quizzes. So this is just checking if the size is 0 or is initializing this capacity here. This kind of initializes the class, I think. Self is like this on JavaScript, or I think Python is also self, if I remember correctly. And this is another library thing. I think that this std pointer is like a raw pointer that allows you to have access to a raw pointer. And then it's basically creating, initializing as a dangling pointer, I think, here. So with capacity, so this is to pre-allocate. If you don't use with capacity on a normal vector and just push, then under the hood, Rust is gonna have to allocate memory, which is gonna be slower. Let's say, for example, you do on a loop and you push a bunch of times, you are forcing Rust to reallocate memory all the time. But then if you initialize with capacity, it already sets up the whole layout. It's a lot faster because you only do one allocation. This is also from the standard library, and I spent some time on other exercises trying to understand how this works, and I think it's pretty simple. It's kind of like the description of what the memory is gonna be, what the memory is gonna look like. That's the best way to put it, I think. So here is just because the class is generic. So the t is gonna be whatever type you use to initialize the vector. That makes sense. So here is basically initializing an array with this type and then this capacity, which is the size of the array. Then it uses this layout to pass to the alloc. And I think alloc is just like, I think C++ or C has alloc as well. It's just allocating memory on the heap. So basically allocates an array with the type of the vector into the heap. And this is an unsafe operation. Have to use the unsafe here. I think whenever you use this alloc library, you have to use the unsafe because you're basically saying to Rust that you are going to be responsible for the memory. And usually when you use the abstractions from the standard library, or if you use the vector, stuff like this, then Rust would manage the memory for you. So it's safer. It basically creates a pointer to that place in memory. It's probably the start of this allocation. You should look into this alloc again and read the documentation again. Alloc. Things alloc. Yeah, alloc, then alloc again. Unsafe function. Allocates memory with the global allocator. Oh. I think it's probably very simple, just like the name says there. So it's supposed to be deprecated in favor of this allocate, the global type when eats and the allocator trait becomes stable. So it just allocates memory on the heap, accepts the layout as the argument. Layout of block memory. So I think that's pretty simple as well. That's the size and whether or not. Oh, yeah, there's a bunch of methods you can use. I think there I'm using the array methods. Weird. So how come there's not really a method, I think. Actually, it probably is a method. Is this calling? I don't understand why. Oh, it's probably not. There is a method. So grow is whenever you hit, I think it's half of the capacity or something like that. Or whenever you hit the capacity, you double by 2 on the standard or the default implementation, you double by 2. But then in this case, we could theoretically change this value, but I think it's here. Check multiplication to capacity overflow. So this is basically handling the error case, like it's kind of like a troll on other languages. And then the message is just going to be capacity overflow, I think. And then this creates, I think like this is the ternary operator on C++, like the version of the ternary operator, this pattern. I think the LLMs use this a lot as well. So if the capacity equals 0, makes it equal to 1. Not sure if this makes sense. But maybe it does. So it's used. Then it uses the layout again. Then allocates here if it's 0. Just allocates one element. So I think that if you don't initialize with capacity, it's just gonna double each time. So the first one is gonna be 1, then it's gonna allocate memory on the heap for one element. Then the next time is gonna go here, which is gonna be the multiple of 2. I'm not sure if I can. Yeah, I can't use Control B. No. This is the downside. The reason why I'm using ZAD instead of VS Code for this is to not mess up the stuff that I'm currently doing, because otherwise I have to like open VS Code first, then run the command so that it remembers. So that's like I have to open the project that I'm working on VS Code first, so that next time that I open on here, it goes to that project instead of going to this training. This is the easiest way I found. So just use another. Oh, I thought about using VS Codium for this. Maybe that's a better idea. That's probably what I'm gonna do actually. Because I want to go to the definition of the. Actually, yeah. When I was checking the solution, I created a temporary project for this as well. And then I was copy and pasting on that project and compiling. Because you can only go to the definition after you compile, because then Rust Analyzer is gonna, which is the extension of VS Code, is Rust Analyzer is gonna allow VS Code to know like where to go to find the definition. Also, here is using a reallocation. So it gets the old layout and the old pointer, and then it extends by the size of the new layout. Pretty easy to understand. I think this is correct, probably. I'm gonna ask ChatGPT again to see if there are any errors or potentially dangerous things. And then depends on what he points out. I'm just gonna do more research and read the documentation to see if it makes sense or not. And so far, I think it makes sense. And this is something that it's kind of confusing to me. And when I was trying to convert micrograd from Python to Rust, the LM was recommending that I do the same pattern here that they are doing. Just basically create like a fake internal version, not a fake, but an internal version of the implementation, and then the real one is wraps the internal one. And it said that this is a common pattern in Rust, but I'm not really sure if it is or if it isn't. That makes sense or not. So it looks like this is gonna be the internal and this is the real one, and then just uses this as the buffer. So it creates the buffer here, capacity just calls the methods. This is the thing that's the reason why I wasn't sure very much, because it seems that it just becomes this like relay thing. The real implementation just calls the methods from the old one. It seems kind of pointless. But I think it's because of the memory, the way that Rust handles ownership and memory. That's the reason why it recommends to use this pattern. But I still don't know if that's the case or not. So this is the std pointer from the other implementation. Just calls the add methods. I think it's pretty self-explanatory. Actually, yeah, this is another thing that I'm contemplating about doing at some point. Probably after I do a few of these data structures, it should go into this implementation, because this pointer from the standard library is just like a normal implement or IMPL. Not sure how to like imp that is like a default one on Rust, and is basically implementing a generic template pointer. So as far as I understand, they embed functionality on each generic template pointer, which allows any a pointer from any type to have this access to these functions. And that's probably what Rust is doing behind the scenes when you do normal operations with types, I think. But then here, when you use unsafe, it allows you to get control over that. So it adds the length, which is capacity. If the length is equal to the capacity, then it grows. I assume that, yeah, the length is increased by 1 each time. I wonder if this is correct or not. Not sure if this makes sense. Is adding the length to the pointer, and then is writing the element there, I think. That's what's happening. It's like increasing the pointer by the length. The reason why I'm not sure is like, shouldn't it be by 1 because you're adding one element? Maybe you should ask that to GPT. So here it reads. This is another thing that is kind of confusing, but I think that's I can't know for sure if it makes sense because I never used in practice. But since I compiled code that uses this and it passes the compiler check and it runs, I think that's like is trustworthy enough to use or to just think that this is what happens, but I'm not 100% sure. But I think here the reason why it's only reading the pointer and this is a pop operation is because after you read, Rust is gonna drop the value automatically because everything works with the RAII pattern. The resource acquisition is initialization. And as soon as the value goes out of scope, Rust deletes the memory for the value. So just by you using the pointer std pointer to read the displacing memory where the element is at, it's gonna delete that memory after it goes out of scope. So I think that's the reason why this works here. And I think that I understand now what it's doing. So like this pointer here is the pointer from the beginning of the array. That's why I was confused there. It's not the pointer from the where the last element was at. So that's why it's adding a length here. It's basically getting to the last element by adding. It's making the pointer that points to the initial element of the array to point to the last element. That's what it's doing here. So the next place you put the next element, and then it writes there. So I think that I'm gonna remove the already more clear to me. And this here is the like this allows you to implement your custom logic for dropping elements. So I assume that internally Rust does the same thing. It implements this drop here for the built-in types, and that's why they delete memory when they go out of scope. But then you can implement your own drop to override that behavior, I think. So it allows you to determine what happens after the elements go out of scope. This is kind of confusing. Not sure if it makes sense. It's creating another struct inside of this drop here. So first it checks to see if the capacity is bigger than 0, and it's going to use the layouts to deallocate with the alloc here as a mutable pointer to an unsigned integer. So this is the pointer. This is probably the pointer from in the beginning of the array. I wonder why it does this. What's it doing here? So it's assigning the pointer to the pointer of the buffer. The buffer is the raw vector there. This is the beginning of the array, and then the capacity. This, which determines the layouts. So yeah, I think it's pretty simple. This is the capacity of the vector, so the amount of memory we are using on the array, and this is the beginning of the vector. So this just creates the layouts, and it's basically saying deallocate is using the standard library dealloc to delete the memory from the beginning to the capacity the layout determines. It's pretty easy to understand. This one I'm not sure. So I think this deallocates the buffer, and then this deallocates each element. That's probably what is going on. It's looping over the length, and then for each one increases the pointer, causes drop in place. So here it deletes each element, and then the guard or guards the guard goes out of scope, and then it destroys everything here. Destroys the buffer. So I think that makes sense. I'm gonna ask ChatGPT about it. Let's do this one. I probably have to redo this because it has the error here. There's most likely gonna be an error. And there's an error because it moves the value, I think. So when you use the v on a loop here, because you're not using as a reference, Rust is gonna delete the value of the memory after this runs. So when you try to use here, it's gonna be a dangling pointer. It's pretty easy, this one. We still have to memorize and understand what are all the patterns to do loops. And the main one that I'm not really sure how it works on Rust is the for I loop. Not sure how you do this in Rust. But I think that probably most of the time you're gonna use the dot enumerate. You call into iter probably, and then right after that you call dot enumerate. That is basically the same as Python. It gives you the index and the value. So that's probably how you do it most of the time, I think. I don't think that Rust has a for I loop. Yeah, so it's saying that it can cause dropping the pointer can cause panic, and then you would have the wrong version, the wrong value of the length. So it's telling me to decrease right away. I think it makes sense. The same here. This. Forgot the pointer. I think I'm gonna have to check to see if it compiles before marking as done. So I'm gonna have to open VS Code, then open the other project there, the temporary project I have. I'm gonna reformat this. Yeah, it doesn't, it's not compiling. It's probably the same. I think probably easier. Sure if it is like this. Maybe it's, I don't remember how to write this. I'm not sure if it's gonna be good to do this or not, but I couldn't think about any better way, at least until now, to because the main thing that I'm trying to train is how to write the stuff myself, so I don't need LMs or agents to write for me. So it's self.buffer pointer as pointer. If I can, but I think forcing myself to rebuild probably, hopefully over time, after I do a bunch of times, is gonna allow me to just know how to do it myself. Oh, I think it is like this. Yeah, nice. Okay, so it compiles and it runs. I'm gonna mark this as a verified solution. The exercise list. And once I'm done with all of them, then I'm gonna really start trying to recreate myself from scratch. So now I'm gonna move to, I'm finished reading this. Then I'm gonna move into focusing on doing the quizzes. Okay, so assume that this is probably an error from what I remember. And I think it's the same thing as the other one, but I'm not really sure actually. So RC, I think it stands for reference count. Reference counted. So it creates a integer that is reference counted as with n here. Then it copies the address of that integer. I think this is about interior mutability. So it's cloning the address with this reference counted to create this thing here, and then is mutating the n here. So maybe it's not an error, maybe it's true. Because this dereferences the pointer. I think it's probably an error from what I remember, but I'm gonna put true here. So I think that what this is testing is whether or not you can mutate a reference counted variable to another reference. That's probably what it's testing. Yeah, so it is an error, but I don't remember why. That's probably just because it can't be mutated. Enforces this property by implementing the deref trait. Implemented the. Okay, so I think that if for things that implement this trait, then you can mutate them. But since RC doesn't implement, then it forces you to not be able to mutate. So one question would be, does I'm not sure if I implemented the. Yeah, I haven't implemented the button to go back to the exercise yet. It would be good to copy the code. Not sure if it's gonna. Yeah, so the default behavior is no interior mutability. So it can't mutate unless you specify the deref mute trait, I think. So refsal allows you to do this. I think now I understand why ChatGPT and other LLMs recommended me to use refsal on when I was trying to convert micrograd from Python to Rust. So they recommend you use refsal and then you wrap that on a RC to hold the values, I think. The reason why is because refsal allows you to do mutable interior mutability. So for the operations of the neural network makes sense because you need to be able to change the values. But then you also need reference count, so I'm not really sure how that works. You need a reference count to obviously keep track of the values as well. I'm gonna ask this next. Let's move to the next one. So this is to output whatever's gonna output there. So it moves the name here, so it's probably an error. Yeah. I have to redo some of this from this category here, the custom core invariants. I think I've done them with an agent, so I had to reformat them so that they are on the same format of the Rust quiz ones. But then some of them are still not. They have this the wrong information. So here is saying that is an error. It makes sense because it moves the name. And then try to use here. Maybe that's fine. So it extracts the name from person with this structuring, and then uses here, and then tries to print person. So I guess that if you added the ref here before the name, then you would compile. Not sure. Okay, so the lesson here is that whenever you have a struct and you move any of its variables, then you can't use the struct anymore, or you have to borrow. Have to choose the reference, I think. So here is using the reference here. So this becomes pointers to the address instead of the value. I think person is a struct. And then here you're cloning, which means you're copying the struct, not using the original one. So the invariant is that Rust doesn't allow doesn't allow you to do things with structs that have partially moved variables. Maybe I could ask ChatGPT or some other LLM if I use ref here, you would compile or not. I'm gonna ask. Oh, so they do the other way around. That makes more sense. Because then you have the reference count of how many reference cells you have, how many pointers should the reference cell you have, and then you also can mutate the value inside of the ref cell. Because the ref cell allows interior mutability. Yes, that makes more sense. Move on to the next one. Rust quiz ones are usually very hard. Okay, let's think about this. So is this structuring the first element, I think? So X in this case would be D. So it would be 1 here, I think. There's also this drop. So I think it's 1. No, it's probably, not sure, actually. Because it is X, I think it does match the value, so it's probably 2. Then it drops and it's 1. 2 and 1 up until this point. So it's dropping. This is for D, not for S. Yeah, so it should be 1, I think. This is 1. Then it gets the reference here. Yeah, this, it kind of goes back to the other one. Because now I'm not sure. I'm pretty sure that it is gonna print something. But I'm wondering why is not an error here. Exactly because of the same stuff from the other example. Because it's using X here directly without using a reference. And then it moves. So in my mind, it should, like this X here shouldn't exist anymore. So like this should throw already, I think. No, I think that here it shouldn't because it's the first time that it's using. But then here it probably should. No, because this is a different one. So never mind. So since this is a different one, I think it does compile. It does make sense. I'm pretty sure it's not gonna be what I'm thinking about. But I think that what makes the most sense is should be 4 here. It's gonna print the X here, and then 3. So it prints 2 first, then drops 1, and prints 4 here, then drops and prints 3. Hmm. So because this thing is used, it means that it drops the rest of the product immediately. That's why it prints 1 first on the first example, and the other one is basically correct. So whenever you use this dot search with this structure, you're dropping the rest of the elements like right away. So the second one compiles according to ChatGPT. I'm gonna do one more, I think, and then stop streaming. That's the compiler. Classes, run expect all. It receives a reference. I think it's pretty easy. Probably true. I don't remember now. What's the... Maybe I should do this self-string now and add the button to go back to the exercise. Because, yeah, I think that's probably a good idea. Because I find that I want to go back to the exercise on a lot of these examples to remember what it was like there. And then maybe to ask questions as well. So the thing is, I'm not for sure if it's a good thing to do this now. I'm gonna do one more, then I'm gonna stop. The size of values is usually one that is very hard for me. I think there's a concept of zero cost abstraction or something along those lines. On those cases, zero. But then here, remember, is something tricky. Not sure how many bytes you use this to represent a boolean as well. I have no idea about this one. We're just gonna guess true. As zero. Zero size type. Pretty interesting. So it's saying that one variable shadows the other because they're true. The second assignment shadows the first one. And whenever you have a simple expression like this, it assigns this value which doesn't have a size, doesn't have size. Yeah, so I want to stop here. Next time, I'm probably gonna do the same thing that I'm doing now. So see you then.